Hello everyone. In before part 5, we have discussed about the speed of a transverse wave in air and also the speed of a longitudinal wave and the speed of a waves in a string. We have discussed about that v is equal to nu lambda and as well as whenever the waves are traveling through a string, then v is equal to root t by mu is the speed equation we have derived. Now Newton has given the first formula for waves in a gases. Means Newton's formula for speed in gases. The first formula given by the Newton. So that's why we are taking that for our ideal gas he has taken that. From the ideal gas we know the equation for ideal gas equation, that is PV is equal to nRT. Here the PV is equal to NABT. Newton assumed that when the sound is propagating in gases, then that will be the isothermal process. The temperature remains always at constant, but so he has taken that from the bulk modulus of elasticity. The pressure is also takes place whenever the pressure is applying. The temperature is exchanging from the surrounding, so that's why the temperature is always remains constant. He assumed that thing, so that's why he got the equation for the P is equal to root of P by rho. This is the first relation, so that's why I taking that this is Newton's formula, but small error is there. According to the equation, Newton's formula of equation, then we can't get the actual speed. The experimental method was not getting the result from that formula. So that's why according to that the experimental value of the speed is 331 meter per second. But according to Newton's formula, we have taken that the theoretical value is 280 meter per second. This is some of the flaw is there, the error is there. So according to this formula is not to be used to find the speed of a waves in gases. So that's why speed of a sound in gases. So the percentage error is 15% due to the experiment. Between the experimental value to the theoretical value, some error is there. That is the 15% of error. That is 51 meter per second value is there. So again, the mathematician Laplace has corrected this error because he assumed that Newton assumed that the process is a isothermal process. He did not accept that the process is not a isothermal process, but the process when the sound is traveling through the waves, means gases, in the adiabatic process. That is not isothermal process, but it's isothermal process. Because of that's not isothermal process, it's a adiabatic process. In that adiabatic process, the temperature does not remain constant because of the time speed for the wave is very fast. In that small interval of time, the heat cannot be exchanged from to its surroundings. So that's why the temperature changes. So that's why that process is a temperature. The process is a adiabatic process. According to the ideal gas equation, the condition is satisfied the ideal condition. So that's why from the adiabatic concept, P into P power gamma is equal to constant relation. If we differentiate on both sides, that P into gamma, if in case of, according to the mathematical formula d by dt of uv formula, if we differentiate this one, then we can get P into P power gamma means for x from the formula of n into x power n minus 1 means d by dx of x power n is equal to n into x power n minus 1 formula. From this formula, we can give the equation that P into P power gamma is equal to P into gamma into P power gamma minus 1 into delta V. And as well as when the formula is derived, again u into v dash plus v into dvu by dt form according to the basic one. Based on that one, then we can derive the equation for that. Then v power gamma into delta v is equal to 0. V power gamma into delta v is equal to 0. From that relation, we can get that the value for the delta p, we should derive that equation, then we can get the value. Then whenever the delta p equation taken to the side, then p into gamma, p power gamma minus 1 delta v, that is equal to minus p power gamma delta delta p. V power gamma delta p. Then if we take this delta will it will become denominator. It will become denominator. So that's why gamma p is equal to minus V power gamma delta p by V power gamma minus 1 V power gamma minus 1 into delta V power gamma minus 1 into delta V. From this relation we can write that this one the V power gamma is taken to the outwards, because of this we can get V power minus gamma. Then bases are equal, power should be added, then minus delta P by V power minus gamma to V power gamma minus 1. So from this relation we can get, we should add it, then it will get to delta V. Then power bases are equal, so power should be added. From the relation we can get minus delta P. So from the equation delta P is equal to minus V power gamma into delta P and by V power gamma minus 1 into delta V. Then we can write that the total value gamma P is equal to minus delta P by, whenever the V power gamma is taken to denominator, then it becomes V power minus gamma. V power minus gamma. V power minus gamma into V power gamma minus 1 into delta V. From this relation we can get minus delta P by, bases are equal, so power should be added, so then we can get V power minus gamma plus gamma minus 1 minus gamma plus gamma get cancelled, then delta V. From this V power minus 1 V power minus 1, then if this V power minus 1 can be write like this, then delta P by minus delta V by V power minus 1 can be written as the denominator for denominator delta V. So that's why we can get that. From we know that from the bulk modulus, when the speed of through the liquids, when the bulk modulus of velocity V is equal to minus delta P by delta V. So that's why we can write that delta P which is equal to P. From this relation we can write that V is equal to root of V by rho is the equation. Then from this equation we can write that root of gamma P by rho with the from the Laplace correction. From the Laplace correction we can write that the speed of a wave in gases we can write the root of gamma P by rho. Gamma P by rho. We know that gamma is equal to Cp by Cv, means Cp by Cv. This is the specific gravity constant, specific heat constant. We can write the specific heat constant gamma is equal to the ratio of specific heats at constant pressure and constant volume. We can write that the ratio for air. If we take in the gamma value for air, the gamma is equal to 7 by 5. If we substitute these values in the equation, then we can get finally, then we can get that the experimental value, that is 331 meter per second. This is about a Laplace correction which is having the Newton's formula is having error. So to correct that error, Laplace has assumed that Newton's formula is, according to the Newton's formula, the propagation in gases of a sound is not a isothermal process. Therefore, the assumption is wrong, but according to the Laplace correction, the propagation of a sound in gases is a isothermal process, because of the forwarding, means the propagation, the sound speed of a sound is very fast. In that small interval of time, the heat cannot be, the temperature cannot be exchanged to its surroundings. So that's why temperature can't be constant. That is the assumption by the clarification, by the correction of the Laplace. We can get the equation, that is V is equal to root of gamma P by rho. That is equal to, we can get that by the calculation, that is V is equal to gamma P by rho is equal to 331 meter per second is the value for speed of a sound. So according to the Laplace correction, the correction of Newton's formula is a Laplace correction. The speed of a sound is V is equal to root gamma p by rho be the equation for Laplace correction. Speed of the value for we can get the experimental value. Then the correction of Newton's formula is the Laplace correction. The next we are going to discuss about the principle of superposition of waves. What is meant by the principle of superposition of waves means? Here the principle of superposition of waves means whenever two or more waves simultaneously meet at any point at a given time, at some time, at any instant, two or more waves are meet simultaneously in a medium. The net displacement of the waves, the net displacement at a given time is equal to the algebraic sum of the displacements due to each time. The displacement due to the each wave of that time means the total net displacement which is equal to the algebraic sum of the individual displacements of the waves which is traveling in a medium is called the principle of superposition. Here the y is taken as the net displacement and the y1 is the individual displacements which are traveling in a medium, that is y1 by 2 up to so on to yn. If the number of waves are present in the medium, two or more waves, we have said that two or more waves meet simultaneously at a point, then we can write the equation. Means, for example, here we are taking that when the wave is traveling like this and in same string, then opposite direction another wave is traveling in this direction. Due to the time t is equal to 0, the starting stage two waves. Each and every wave will travel to the medium is that no others present in the medium. No other waves are present in the medium. They behave like that. No, there is no any other wave present in the medium. Only that wave is traveling to the medium. Like that, then a wave is traveling through this direction. Then another opposite pulsive wave means another wave is traveling in this direction. Then after some time, there will be the displacements will be they both cancel with each other because they are having the same amplitude and same frequency, same direction. So in opposite direction. So that's why they will be cancelled to each other. Then finally they will come to like this. So here whenever they are moving in opposite direction, they will change in phase. If the both are changing in phase, then we can get this equation. If we want to find out the principle for superposition of waves for mathematically, for example, the y1 with the one wave is equal to f1 of x minus vt with the wave formation. Wave equation for the first wave and y2 with the f2 of x minus vt with the second wave equation. Then according to the principle of waves, y is equal to y1 plus y2. Then from that equation, y is equal to y1 plus y2, that is equal to f1 of x minus vt plus f2 of x minus vt. From this relation we can get for n number of waves also we can write that y of n is equal to, with respect to its position and time is equal to, we can write that. Similarly, I is equal to 1 to n f of I of x minus vt with this is the mathematical equation for the superposition of waves. Means whenever the first wave equation is y1 is equal to f1 of x minus vt and y2 is equal to f2 of x minus vt with the second equation. From the relation, from the principle of superposition of waves, we know that the net displacement of the waves, displacement of the waves in a medium which is equal to the algebraic sum of the wave displacements of the wave, individual waves in the is called the principle of superposition of waves. From that formula we can write that y is equal to sigma I2 y is equal to 1 to n fy of x minus vt with the principle of superposition of waves formula. Once again, the definition of principle of superposition of waves is two or more waves meet simultaneously in a medium. Two or more waves meet simultaneously at a point in a medium. At a point in a medium, the net displacement at a given time. The net displacement at a given time is the algebraic sum of the displacements. Algebraic sum of the displacements due to each wave. Due to each wave at that time. When the time the total waves meet simultaneously at a point, at that time the algebraic sum of the displacements due to each wave is called the principle of superposition of waves. This principle of superposition of waves is the basic to the phenomenon of interference. Interference means whenever two waves are simultaneously meet, depends on one another, collapse on one another. That is called as interference. When the waves traveling in a medium, they will travel like this. One wave is moving in this direction, it will behave like the thing that it will behave like A. There is no another wave is traveling in the medium. Then also another opposite will change, different change phase in opposite direction. When they meet at a point, two waves meet at a point, they cancel each other. Then the final displacement becomes y is equal to 0. Because of there is no any y1 displacement, there is no any y2 displacement. So that's why the net displacement made at a point is a 0, like this. If in case of both waves are traveling in the same direction, both waves are in the same direction but small phase difference is there, then we can get the equation for that like this.